Hello, my name is Mark, and today's lesson is on energy. So this is an introduction to energy required for the IGCSE Edexcel syllabus, and we will cover it over a number of lessons, and we'll have a video on each one, a recording of the slides that I use when I normally teach it to my class, and this will be shared on YouTube. So please share it with your friends and give us a like if you can, and subscribe if you want to know when the next lesson will be ready. So in my class, normally I get students as they come in to think about what they know about energy already. So presumably you have all studied it in your schools in before GCSE, and you should know something about energy already, and this allows students to come up with some notes. I often use the back of the book where students can write down what they know about energy and then get them to discuss it with their partners. So try to get used to this software. I'm using it for the first time, and it seems like it doesn't automatically go to the next slide with the normal cursor keys, so I think I have to use this. So I often get the students to say, well, where does our energy actually ultimately come from? And I'm referring to, of course, when the fact that we're living on a planet, and therefore the sun is the ultimate source of all of our energy. And then you can have a discussion with the students, and they may have some questions that you can just discuss with them. So for example, I give this example of if you're eating meat, where the energy comes from. So the beef comes from cows, the cows eat the grass, and the grass, of course, photosynthesizes its energy using sunlight. So the energy has gone through a number of stages, and the ultimate source was the sun. So then I show students what we will cover in the first section, which is really to do with energy transfers. Now there has been recently a change in some of the vocabulary used in GCSE exams. So we now have 8 stores of energy, and they're listed here as chemical, kinetic, gravitational, elastic, thermal, magnetic, electrostatic, and nuclear. And you'll notice there is no reference to electrical energy, and there is no reference to sound or light. So this is something that I point out to students. So energy stores is where there is energy that can be stored in different forms, and we're going to go through this in the next slide, rather than energy transfers, which is how energy changes from one form to another. So this is an important distinction from the old type, where a light and sound would have been also put as types of energy. So the types of energy stores is the next part of this course, and I have listed the 8 that we just gone through on the left, and I would then get students to come up with 1 or 2, or as this slide says, 3 examples of such sources. It doesn't have to be 3. And that's why I've put at the bottom of the box, are there any other types of energy that students may have come across? And hopefully some of them will notice that light, sound, and electrical are missing, although there is electrostatic and magnetic, which when you study physics at a high level, you will realize that they are both part of the electromagnetic effect. So this is something to deal with in the future slides, because I've kept the slides with electrical energy put in. So then energy transfers refers to what we were just talking about, the pathways by which energy can be transferred from one form to the other. So mechanically would be when you have a machine, for example, like an electric motor. The example that often comes up in GCSE exams is roller coasters. So to get a roller coaster to work, first you have to get the passengers on the roller coaster. You then use an electric motor to kind of get them to a high point gravitationally, so they then have a store of gravitational potential energy, and then it's released and it becomes kinetic energy. But we will go into the details of that later on. Electrically, we'll go through in the next slides. Another form of a pathway by which heat transfers from hot to cold objects, and they will be studying conduction, convection, and radiation. And radiation itself is another pathway by which energy can be transferred. For example, from the sun, energy is transferred by radiation to us through a vacuum. And of course, that brings in the concept of electromagnetic radiation, which we will have studied in the waves topic, which you should have done before the energy topic. Okay, so I get students to write down examples of each type, so they can come up with their own examples before we go to the next slide. Okay, so to describe an energy change, you have three stages: the input, and the output forms of the energy. As I mentioned before, that electricity is one of the major uses that we have in our homes. So electricity is going to come up on a few slides, and electricity is a pathway by which energy can be transferred. So if this electrical light bulb is getting light and heat, if it was used in a circuit, it could be in a lab, it could be with a battery. But if it's used in a home, the electricity would have come from a generator. So those are something that you need to have explained. They've already studied electricity. So the starting energy you write down first. So it could have been that you've written it as chemical if it was a battery, or electromagnetic if it was a generator. The arrow represents the direction of the energy transfer, and then on the right hand side of the arrow are the types of energy which are your output. Okay, you can then give students time to see if they can draw a similar energy transfer for the examples given, which is an electric heater, a rock about to drop. So in fact a falling rock would be how I would explain it to them, and then arrow about to be fired by a bow. Now of course, a rock about to drop, the work is actually being done by the Earth's gravitational field. So I would like some clarity on that myself as to what is the energy pathway in that energy transfer. For the third one, it is of course a mechanical system where the bow and arrow is a kind of machine. Okay, so that's brings us to the conservation of energy, and this is probably where I would make sure, if it hadn't come up already in discussion with the students, that energy can never be destroyed or created. It can only change from one form to the other. Therefore, you always have the same amount that you start with as you finish with. So, or the energy you finish with, it will always be equal to the energy that you start with in any system. So again, this example of light bulb is given, which I think is a good example, although, as I mentioned, I do have an issue with the fact that electricity is not a store of energy rather than a pathway. So again, you'd have to say, where did the electricity come from? Heat is then defined as a wasted form of energy because it is lost to the surroundings, whereas light is the example you want. And then you have other examples that students can again discuss in pairs, or if they're working at home, remote learning, then they can come up with these examples. It would be a good idea to have model answers set out as well for students, and this is, in my class, I would normally do it in Teams or in OneNote, which is also a part of Microsoft Teams. The next slide takes us through to the concept of conservation of energy and therefore efficiency, and you then define efficiency as how much of your input energy is converted usefully to what you want. So this TV is using electrical mains supply, and the amount it's using is 200 joules, and it's giving out light, obviously, which is a visual, the sound that you're listening to, and then also some of it will convert to heat, which is the concept we met in the previous slide. So the useful output would be 120 in the equation. So you divide 120 by the energy input, which was 200, and if you want it as a percentage, you multiply by 100, or you can leave it as a fraction. So this equation students need to know how to use for their GCSE, and in the next slide we will give them some alternative examples. When we're discussing this, they also need to distinguish between useful and wasted, otherwise they've missed the concept. So these examples are given to them, and you can either stop the slide now and to work out, see if you can work out these examples yourself. Otherwise I continue and I move on to representing the efficiency using what are called Sankey diagrams. Again, Sankey diagrams will be required for the GCSE exam, and you have to be able to show the efficiency and the energy transfer represented visually using a Sankey diagram. The width of the arrow represents the amount of energy, and students need to be aware that they need to draw them roughly to scale and to show, for example, the blue part of the arrow is 2 squares wide, the pink is 10 squares wide, therefore the green is, which is the wasted energy in this case, is 8 squares wide. So you haven't lost energy, useful is 20, wasted is 80, and you can then work out the efficiency as well using these diagrams with the mathematics that we have just learnt. You then can give them alternative questions where they can look at it. We give them an example of a kettle, which, as well as heat, also produces some unwanted sound. So that's quite a good extension to the previous question that we looked at. And the students again can work out using the width of the arrows how much the useful output is. And here's a typical computer, and you'll notice that on this slide we're not using joules, but we're using joules per second, which is bringing in the concept that efficiency can also be a ratio of the rate of use of energy, which is the power output or the power input, and that's given, and they've studied this in electricity as watts. So this takes students through the first part of this topic on energy. And then the final thing, if you have time, you can have a quick discussion of advantages and disadvantages. Where electricity isn't available, for example, you can have alternatives to electrical systems, or you could have your own generator if you're living off the grid. So this is a good place to finish the first video on the introduction to energy for IGCSE Edexcel physics. So hopefully you have got some a better understanding of it now, and you should make notes based on the syllabus which was in the first slide, which I will take you back to show you how much we've already covered in the 15 minutes or so that we have taken to go through these slides. So that's what we wanted to cover. Energy transfers, energy types, the principle of conservation of energy, which is energy can never be destroyed nor created, it just changes from one form to the other, and then the mathematics of calculating the efficiency of a system is important, and then the use of Sankey diagrams as a visualization and to be able to analyze different situations. So we'll end the video there. Please give it a like so we get more views, and subscribe if you want to know if you want to be notified when the next video is